Imagine you're on a walking tour in the city. You are too hydrated and cannot find a public restroom. A geographer might ask, which neighborhoods in the city have public restrooms? But a political science student might ask, who decides where public restrooms are built in the city? And a public health student might ask, what is the impact on health by denying public restroom access to certain parts of the city? These are three examples of geographic questions, each informed by the background of the person doing the asking, but they are still geographic nonetheless. In this video, we'll talk about the kinds of questions geographers ask in order to provide you with a framework for thinking about your own majors from a geographic perspective. Then, we'll take a look at a couple of ways of going about answering those questions. As we discussed in our previous video, geographers are curious about the where and the why of spatial phenomena, that is, spatial patterns and the processes that caused them. There are many ways to ask where and why, so let's go over a few common kinds of geographic questions and provide examples. We have location questions, spatial pattern questions, relationship questions, change over time questions, and impact questions. Location questions ask, where's something happening? Like, where are the best locations for solar power generation? Which areas have the sunniest weather? Spatial pattern questions ask, what patterns do we see across space? For example, how are cases of heat illness distributed during the summer? Is there a pattern to who is getting sick and where? Relationship questions ask, how are phenomena related to each other in space? So for example, how do women hikers experience outdoor recreation? In this question, we're approaching gender and outdoor activity as two spatial phenomena that can be understood together. Change over time questions ask, how does something's location or pattern change? How has coastal erosion affected tourism revenue over the past decade? Have tourists been discouraged by cliffs falling into the sea? And then impact questions ask, what is the effect of one phenomenon on another in space? So how does rain affect voter turnout in local elections? Do folks end up staying home, or is this prevented by mail-in voting? And while each of these questions is related in some way to physical geography, geographic questions are not limited to geographers or to geography majors. They can be applied from any disciplinary perspective as long as they consider location, spatial patterns, relationships, change, and/or impact in terms of space, place, or scale. In addition to the types of questions we can ask, geographers also often narrow the scope of their questions by providing additional context. Some common ways to narrow the scope are by specifying a place or space, like asking the question about California specifically, or about warm climates. We can specify a period of time, like pre-COVID or in the last decade. We can specify the scale, so by country or locally. And we can specify a kind of person or a species, like for senior citizens or among beavers. Narrowing the scope can make it easier for geographers to answer the question later by only focusing on one part of a phenomena. Like other scientists, geographers use systematic approaches to answer questions. That is, we investigate based on a set of procedures. But there's more than one model or system of how science works. If you've taken a science class, chances are you may remember the scientific method. This is the traditional linear process for doing science. You make an observation that sparks a question. You form a hypothesis or an educated guess based on information you already know about the subject, and then you design and conduct an experiment. From the results of that experiment, you decide how well your question was answered and whether you need to try again. And either way, you share your results. So this model is a good introduction because it emphasizes careful observation, testing your ideas, and drawing conclusions based on factual evidence. But real science, especially in the field and with multiple stakeholders, so people who care about your results, it can look a lot messier and a lot less linear. The Understanding Science project from UC Berkeley offers an updated model. It shows that science is a process, not a checklist, that we do science in community with other scientists and not as lone individuals, that science is creative rather than rigid, and that science evolves and can be revised rather than staying fixed. So while the How Science Works model has testing ideas as its core, it surrounds the scientific method with updated processes that feed into it. For example, while doing field research, you might observe something unexpected that sends you on a whole new research project. Or a project might require that you seek additional input, perhaps from a local expert in the community. And when you get to the end stage of sharing your results, you might find a way to apply them for the betterment of local conditions, like improving conservation or disaster planning. In geography, this flexibility matters. Sometimes we can run controlled lab experiments, but often we rely on field measurements, satellite data, and historical archives, looping between observation, interpretation, and refinement in collaboration with others. On Canvas, you'll find your first forum post assignment. Your task is to draft and share geographic questions from the perspective of your own major. Whether you're pursuing a degree in engineering, business, or art, you can ask where and why there. I won't ask you to actually conduct the research, so feel free to go as big as you want. Start by reading through any questions already posted, and then share your own. You'll then respond to your peers from different majors. So look for overlaps between disciplines or propose a way to test one of their questions, keeping in mind the traditional scientific method and the updated How Science Works model. In the next video, we will cover geographic tools, including maps, geographic positioning systems, also known as GPS, geographic information systems, or GIS, and remote sensing, which involves technologies like satellites or drones. Thanks for watching. See you next time.